and getting signed in, getting over those humps of getting connected, which can be challenging sometimes. This is the third of a 5-series session. Already we have heard from Larry Junk. Dr. Larry Junk talked about health and climate, and Chris Olson talked about the impacts in the Great Lakes. Tonight, we're going to talk about how could we keep to 1.5 degrees? What actual physical things would we have to do or change? And what policies could we put into effect to keep us at 1.5 or 2 degrees? And then there are 2 more sessions. Next week, we have, that would escape me. We'll have Ann Ellingson talking about social justice and climate, and who's going to be impacted and who might be impacted by different solutions and in what ways, and how do we keep the transition to a sustainable energy system equitable for people. And finally, the 5th part of the series will be in 2 weeks, where we'll have a climate trivia session, which we've done that once before, and it's a lot of fun. There'll be some questions, and people will be able to sign up as groups and compete for some pretty amazing prizes. Maybe not too amazing, but some kind of recognition of great skills and knowing about different aspects of climate. If you have questions, and I'll just go over some housekeeping here. If people now have been on Zoom meetings probably a little bit more than the case was 3 or 4 weeks ago even. But for now, people are muted, and we're just going to try to keep things quiet for a little bit. A lot of the session tonight is going to be interactive, so I'm going to want people to raise their hand, either raising your hand through Zoom, or you can physically raise your hand in your screen, and Kunal will be watching and can pick up on that. And you can also enter a question via the chat. Let's see. Yes, just a note here about how to find the chat window at the bottom. And if you've got any questions, you can put a chat question in. If you have any questions about questions or how this works, you can put that in the chat window and ask that question, and I'll pick up on that. So Kunal and I are both members of Citizens Climate Lobby. I know some of the people who have called in are members or are aware of Citizens Climate Lobby. It's a little bit misleading a name. It's maybe could also be called Citizens Climate Education. It's a nonprofit, nonpartisan organization. It has almost 600 chapters throughout the world. The mission of the organization is to educate people about implementing a solution to the climate crisis. And we agree along with many experts and economists, that the most effective method is going to be a carbon fee with a dividend. It's not going to be the only thing that's needed, and we'll talk some more about that tonight as we go through this interactive session. But it's a very key part of being successful at transitioning to a sustainable energy system. So where are we now? I don't think this is going to be anything new to people. This is what the CO2 levels have been in the atmosphere. This is roughly the most recent 800,000 years. And you can see the yellow line at the right-hand side of your screen is telling the dramatic story that we have unprecedented increases in the CO2 levels since we started making a lot of use of fossil fuels. And we've greatly exceeded any level we've had in the last 800,000 years. Here's a similar graph showing the temperatures. This is a much more recent. This is in the last 150 years roughly. But it's also showing that, of course, as we know now, we are heading into or in the midst of a period of unprecedented rates of change of temperature and high temperatures. So this is a projection. If you look at the years across the bottom here, and we're going to look at a screen like this as we throughout the evening, but you can see the years are there, 2000 up to the year 2100. And this on the screen is a plot of temperature. And as we all know, the issue we've got is global temperature rise, and this is a projection shown to the end of the century of what we can expect. So we're here at 2020, and we're going to, with business as usual, which of course we don't want to have happen, but if with business as usual, what you see on the screen is temperature rise of 4.1 degrees C by the end of this century. Our goal, of course, is to stay in this yellow or in this gray banded area with the dotted lines at 2 degrees or 2 degrees, 1.5 or 2 degrees of temperature rise. So that's what our goal is today. We're going to, and what, of course, again, I think I'm preaching to the choir, but should we not be able to be successful at changing, we're going to have more record-setting temperatures, more extreme weather events, rising sea levels, more severe droughts, increasing ocean temperatures, species extinction, and a lot of secondary effects from all these effects. And just a more graphic illustration of what it means to, if we were to allow 4 degrees C to take place, if we weren't successful in keeping fossil fuels in the ground. Here's a shot of lower Manhattan where Wall Street is with the statue. And then this is what it would look like with 4 degrees of warming. You can see nothing but the tail. So we don't want to get there. So tonight we're going to use a simulator which is called En-ROADS, which stands for Energy Rapid Observation and Decision System, which is why they always refer to it as En-ROADS. It's a lot easier to say. En-ROADS is a simulator that makes a projection of what will happen with temperature and a number of other values that are based on our fossil fuel use, including things like CO2 levels and energy use. And let me see here if I got the right page. Yeah, okay. Whoops, okay, I wanted to get that. Okay, so this is the simulator. This is the way that the simulator is controlled. And this is, as I mentioned, the name of the simulator is En-ROADS. It was developed by MIT, Sloan, and Climate Interactive, a nonprofit organization out in Boston. And on the upper left here, we have a graph. In this case, right now we're showing sources of energy with coal and oil and gas, renewables, bioenergy, nuclear, and energy sources facilitated by new technology, all shown here on the left, plotted from the year 2000 up through 2100. Right now we have a graph on the right of temperature change, which we saw that one earlier. And then on the bottom, we have a bunch of different, these are sliders, and a bunch of different areas that comprise the energy system, which we can make changes to. So if I look here, one would be renewables, where we could take and I can move the slider around. And if you look, you can see the plots of temperature and of energy usage moving around as I move the slider. And this is, it might look just like the manipulation of like a PowerPoint, but there are actually, they say, 16,000 equations that are run whenever a change is made on the bottom of the screen. So, as I mentioned, this is going to be interactive. So I want to remind everyone the goal is to make some changes here on the bottom so that we're successful at making the energy rise over the next 80 years no more than 2 degrees C, and ideally less than 1.5 degrees C. And as I said, we're going to change these sliders, and that will have an impact on what happens to temperature. So for the first run, I just enabled renewables by simulating that we change from business as usual and we highly subsidize renewables. And if we look at the temperature change chart here on the right, you can see the business as usual is the black line, the thin black line. So that stays the same. In the current scenario, so in this case, simply subsidizing renewable energies, we have decreased the temperature rise. Instead of 4.1 where we started, we are at 3.9 degrees C. So, that didn't do the job that we need to do, so we want to make some more changes. And we can look here and just look to see what happens as we change. I'm going to switch this up here to highly subsidized. And then we have a way to show this changing and unchanging. Well, oops, I got that. Move it up here to subsidized, and I'm going to. So here it's jumping from the business as usual scenario to highly subsidized renewables. And on the left here, you can see what happens to the use of different fuels. With renewables highly subsidized, the green line goes up. It competes.
So, I mean,
same level
what
as
an awful thing to have those kids.
Oh. What was that? So the first question I have is, what sorts of things are people doing, or do they think we could do to impact climate change?
Clark, so we've got our first question actually. So maybe,
Great.
I think, let me, Scott, if you want to unmute yourself, maybe you can go ahead. Or
just a quick question. Sorry, I thought that I might see a parallel decrease in something when you increased renewables since temperature went down. I don't know why increasing use of renewables made temperature go down if there wasn't a change somewhere else. Producing renewables takes energy. You're just increasing overall, so temperature should not come down.
Right. Okay. So great questions. Great questions. And that really is the purpose of tonight and looking at this simulator, is to make a change, think about what you expect might happen, and then analyze what actually happens according to the simulator. So you are suggesting that, well, was one of the questions, why does it go down at all?
I don't see that it's saying if we use more renewables, we are using more of something less. There's just an overall increase in energy use, which would increase many other things, including the production of the renewable energy, windmills and things. So I don't see any reason that it would come down. Okay,
so if we take a look here, I'm gonna toggle renewables on and off, subsidized compared to business as usual. So the simulator is saying, yes, we get the green line going up, so we're going to have more energy provided from renewable sources. But what happens to competing sources?
I see. So it's moving those on its own with some kind of sociological analysis. I expected the sliders to move. I'm sorry. Okay, thank you.
Right. The sliders are all inputs, and then the results are shown in the graphs. You got it. So yeah, why doesn't it go down more is a good question. And if take a look at, as I turn this on and off, what's happening with energy use? Well, one of the most carbon intensive energies is coal, and I'm really helping out renewables, but what's happening to coal? It's on an upward trend in our present era. And if I subsidize renewables, the slope changes a little bit, but it's still a significant part. And it's at the end of the century, with highly subsidized renewables, it's at a level of renewables, but still above oil and gas and all the others. And since it's so carbon intensive, it still is a big contributor to greenhouse gas, which therefore then is a contributor to that blanket around the Earth, which is holding heat in. And so we don't get much of an improvement for just subsidizing renewables. So other ideas, things that you've done or you're thinking of doing maybe in your own home or you've heard people talk about?
Let's see. David, you can unmute yourself. David has raised his hand.
Yeah.
I just put in 2 brand new patio doors with low E glass. Fit that in the model.
Okay, great. So we've returned everything to status quo, and David has done some things with energy efficiency in building and industry. So we can say, David, and let's say everybody, this is a good thing to mention, the simulator is a global simulator. So it's not just the US, it's saying, if we did this globally, what would be the result? So I'm going to put patio doors in everyone's home, or I'm going to make a similar change, and that's what changing this slider will do. So let's go up here and say, we've increased the energy efficiency of buildings. So I'm going to make this so we can toggle it on and off. So let's see what happens. So with just that change, we get an improvement on the overall temperature gain. From 4.1, it goes to 3.8. And you can see the energy uses here. Oops. Oh, yeah. Okay. We have a decrease in coal. We have oil that's getting depressed here. But what do you notice about these curves here? Even I'm going to move this energy efficiency up even higher. So David puts high E glass in his patio doors, and it also has a contractor come in and seals the house up, and they put in a bunch more insulation, and he puts in a heat pump. And so you'd think that, that might be a home run or something, but we're still only getting to 3.7. And what happens to energy? We'll make this go on and off. You can see the curves here. So coal takes a big hit, but look at what happens between now and 2040. And remember, we all know it's 2030 in between these two lines that the IPCC says we need to take significant action in these next 10 years in order to have an impact over these next 80 years. And what does oil do here? And what is coal and what's gas doing? I'm going to toggle this on and off. By the end of the century, coal is significantly changed. But the slope is still slightly positive here. And in the next 20 years, coal and oil both are on the uprise. In fact, they don't change a whole lot with and without this improvement. They're kind of untouched. Does anybody want to venture a guess why that is? Oil didn't get, it got depressed ultimately here as we implemented these changes, but oil and gas and coal still were big players here. Not much changed at all in the next 10 years or 20 years, 30 years even.
Well, it looks like a significant change.
The next 20 or 30 years?
Well, as you toggle it, it changes a bit.
Yeah, and I've been doing different amounts of toggling, or different amounts of, here, I'll do this one on and off.
Yeah.
Well,
Well,
look, 20 years, not too much, and then at this level of increase, yeah, it flattens pretty well.
yeah,
Oil just has that momentum factor.
yeah. Well, we'll still have to.
At all to the type of building or the number of buildings in the next number of years. This is saying buildings are static and those buildings becoming more efficient. But as we build more buildings, as we build different types of buildings, this simulator doesn't take it into account.
So to answer that question, I think the simulator does sort of take overall GDP growth things into account. If you'll notice, one of the sliders also deals with population and economic growth. And with that, it's also sort of factoring in things like, okay, maybe the average, if you have this much population growth and this much economic growth, then you might see an increase in the number of cars or people move large dwellings and so on. So there is some, factoring in of, increased resource usage. And
But think of the amount of pollution in China just because of their economic growth over the last 30, 40 years. And even if they had made every building absolutely 100% efficient, they still would have had tremendous coal plants and other forms of energy, and leading to the pollution that they've had because of the total economic growth. But also think of the number of buildings they built. They built entire cities in the last 50 years.
Yeah. So, and in this simulator, there are, let's see. I've got a competition between Zoom and, maybe I can move this somewhere else. Oh, shoot, I can't get to the, let me change my screen. The simulator does take into account population change, and they have some particular assumptions on what the increase is on population, which you can alter if you'd like.
No, but I'm saying you've only changed building efficiency. You haven't changed population. You haven't changed anything else.
That's correct. If I were to change population, then let's just try that. If I change population here so that the growth rate is less, what do you expect to see here? If we had some way we could turn down the population growth. Oops, I touched my screen. Does somebody want to suggest if we're down here, we could expect some kind of an improvement? If we educated women throughout the world to a higher degree, we know that that leads to childbirth, later childbirth, and fewer births overall. So that would slow the growth rate down. And if we look at that, you can see, again, we get some depression here of our energy use. We can look at, let's see here. Here's what our overall energy use looks like. Black is business as usual, and this is what we've done from business as usual by changing population and energy efficiency. We brought this line down. So if we restore population growth to the default assumption, it goes up a little. If we have more population or a slower rate of population growth, this starts to slope down, as you might expect. Another interesting set of graphs that this chart computes. I'll take a look here. These are projections as you go from left to right here. Each of these has an effect on the graph to its neighbor graph. So if we start on the left, global population, this is what's projected. That would alter here if I change the population rate slider. So we're not we're not getting overall growth finally towards the end of this, or the last 30 years of the century, if we change the population presumption over here. This global population has an impact, or no, I guess in this case it doesn't impact the per capita, the GDP, but the gross domestic product per capita is shown here, which some of the sliders have an impact on. Well, the energy density of the gross domestic product is shown here, and the blue line is a little less because with our more efficient buildings, the an increase in GDP doesn't have the same effect as it would if we had less efficient buildings. So there's an improvement in the energy intensity of GDP. And now the carbon intensity of the energy is shown on this graph, and it's going down because we have more, there's some slight use of renewables. But if we were to step up the renewable use, the carbon intensity here, what do people think? What would happen? The carbon intensity of our energy, if we increase renewables, is going to go up or down?
Down, our carbon intensity should be down.
Should be down, right? Yeah, so there I added some more renewables and the carbon intensity went down. And so this is the resulting graph. If we take the product of carbon intensity of energy and energy intensity of the GDP and GDP per capita and global population. So if we multiply these first four graphs, the product is our overall CO2 emissions from our energy use. And it goes down a lot from business as usual with the changes that we put in place here. But as promising as this looks, we've got a big deviation from business as usual, and that's great. But what are we doing on temperature now? We started at 4.1, we're at 3.4. So we've done some in fact, some of these could be very difficult to do, and we're at 3.4, so we have more work to do.
Clark, we've got a couple of questions asking what would happen if we planted 1 trillion trees.
All right, great. I'm going to put these back. We can restore them if we want. So that comes under the classification for the simulator of afforestation. That is planting more plants so that we get more carbon captured out of the air. So I'm going to go back to the standard case here. I'm going to go just reset things. So I'm going to really increase forests. High growth, even to go all the way to the top of what it allows. And I should have asked this in advance, but we did see that it decreased. The temperature increase was not as high as business as usual, but it wasn't, a game changer, right? I'll turn this on and off. And take a look. I'm going to toggle this so it goes on and off. Here it's with and without that change. What happens to the energy use? We've got some sequestration of carbon, but the energy use goes on without any change, right? So these don't change, even though we've got a trillion trees capturing the.
Clark,
yeah.
Clark, I think Jerry has a question related to the slider as well. Jerry,
Sure.
Maybe you could unmute yourself and go ahead with your question.
Yeah, I think I'm unmuted.
Yeah.
Yeah, so I guess this is related to the deforestation and methane. A lot of people are looking at the impact of animal agriculture on global warming, and everything ranging from it has a 15% impact all the way up to at least a 40% impact. So I'm curious what happens with the slider with this particular model when changes are made. That's going to relate to deforestation because
Yeah.
and as well as methane. And I'm also curious what the inputs are on those topics as well.
You mean what it is we're changing when we do this?
Yes, yeah, and what they're looking at in terms of methane production.
Yeah. So if we evolve to less beef and more vegetarian consumption, we're going to have more land available. We won't be deforesting at the same rate for pasture land. So and you can expect there'll be a change. I'm going to change this almost the whole way. And I'll also, let's do that first. Does somebody want to hazard a guess for, we've done a crazy afforestation. And if we do deforestation, I'll go ahead and do that. People can think, how much do you think it might change? So highly reduced deforestation. And for people that might want to, you can go to enroads.org, and with a few clicks, you can get to this exact same panel. You could run this right now if you want. And if you do that, when you do things like deforestation, you can look at these 3 dots and click on those, and you can see exactly what it is you're changing. Like, what does that bar graph, what does that slider actually do? So in this case, it's impacting the rate of deforestation, either increasing it from where it is, or, oops, that's decreasing it. This is increasing deforestation, which is, let's see, emissions are land use and forest. No, let's see, this must be, yeah, so we're taking more carbon out of the atmosphere. We have a negative here, so this is, yeah, okay, so this is the desirable direction to go for carbon capture. And this is the not so desirable. And this is negative already because of our earlier afforestation. Otherwise, this would be on the same line. So our afforestation, all those trillion trees, they did impact our carbon going into the atmosphere, but not, I mean, these numbers, they're not zero, but these are not significant numbers in the scheme of things because the incredible amounts of fuel, fossil fuels that we're using. So I'll go back here. That was just a demonstration. If you hit on these 3 dots, you get more information and more description of what the slider does. So 3.9, we're in the right direction. Now let's take out the gas emissions from our friendly cows and other livestock. So I'm going to reduce this, work my way down. So it turns out, as people know, I would say most of the people on the call are familiar that methane is a very powerful greenhouse gas, and our livestock system is a very big producer. And just this one slider has a pretty significant effect. That's a ½ degree C from just having more control over methane, which, part of evolving to using less cows and livestock would be an improvement in our methane emissions. Methane also is generated through our use of fossil fuels, because in the transport and relocation of oil and gas, methane is lost. It's just a normal way of doing business. It's just not that expensive a gas, and it's not that well regulated. So I'm going to return, we'll leave some deforestation in, and we'll leave some methane. What other things? How about energy changes? Or how about new technology? Or how about we could all buy electric cars? Or what would people like to try?
Yeah, I think I'd like to try electrifying both buildings and transport.
Okay. So we're going to electrify our buildings. We can get our heating and cooling, instead of burning oil or gas, we can do it through, let's say, heat pumps or some kind of resistance system. And here's electrification of our transport system. So we can buy electric cars, and we would then not use any fossil fuels out on the road. We wouldn't have any emissions while we're out driving. And check this out. We did all that work. We electrified the fleet, or we worked on that. I'm going to go way up here. Highly incentivized electric fleet. And we'll highly incentivize electrification of buildings. And how about that? So all that work, all that legislation or incentives or tax subsidies, and we really, I think we were at 3.4. We're at 3.5. So we got 1/10 of a degree out of that. So why is that? Everybody's, we've got 50% of the new fleet going out, and they are, Teslas or General Motors or, almost every car company now is doing electric. But what happened? We didn't solve our climate problem.
I can hazard a guess at this one.
Sure.
It's because we haven't changed our energy supply at all. You still have to provide electricity for all those vehicles, but if it's still coming from coal, oil, natural gas, you're not really going to make much difference.
Yeah, great. Did everybody hear that? We did electrify. We're going to draw a lot of energy from electrical sources, but our sources of electrical energy, unless we make some changes, are very heavily weighted toward, especially for electricity, weighted towards coal. We use a lot of coal. Coal is fairly inexpensive to get out of the ground. And take a look at I'm going to take this electrification on and off and see what happens to coal and to oil. So in the case of, I'm turning the electrification of the transport system on and off. And coal goes up because we're charging our electric cars with electricity, which is conventionally from coal. And what happens to oil? Okay, to oil, which is refined to make the gasoline for our current cars, that's depressed in years going out. But it's offset by coal in a pretty big way because we are not impacting global warming very much. I'm going to turn up the electrification on the car. I'm going to turn down electrification on vehicles and just see what we get there. Or, I'm sorry, turn up electrification on buildings. So with and without, we can see that renewables are favored a lot here because they can have more of an impact on non-moving, like with solar panels and other things on buildings, and they can play a big part there. And what else do we still have coal being very favored here. And we have bioenergy. Let's see what else is, yeah, nuclear is going down some. So that's a little bit disappointing, but as the earlier speaker mentioned, that's due to the fact that we haven't done anything to change our electrical generation. So maybe we should take a look at that.
Yeah, so Clark, I think one question that's come up is, could we also look at nuclear?
Nuclear, okay. So we've got electrified buildings and cars, and now let's do something with nuclear. So we're going to make nuclear, we're going to subsidize it so that we have more generation capability with nuclear. So I'm going to turn this, make this go on and off. Highly subsidized, and we'll toggle this a little bit. So we see, okay, so first of all, 3.4 goes to 3.1. So a little bit of a change there, that's good. And what happens here over on the energy sources? Where are we getting our energy from now? We've depressed coal quite a bit. And of course, as you might guess, nuclear is way up there. Renewables, what happened to renewables? Let's go back and forth here. So renewables take a hit. What's that all about? The green line here for renewables, with business as usual on nuclear, we've got more renewables than nuclear, but when we subsidize nuclear, that becomes a more desirable go-to energy source, so we're gonna, renewables are not gonna look as favorable. Because just taking those changes, all things otherwise being equal, renewables are gonna cost a certain amount. They don't, they still struggle with storage. And now we're going to have nuclear come along and say, hey, we can run night and day with and without wind. And renewables doesn't have anything favorable on price in this scenario. So we're going to get a lot more nuclear. And likewise, if you go the other way with nuclear, the other energies are going to pick up. So what can we do to, well, let me just look at one other thing. What is going on here with oil? No matter what we've done, I'll change this. the trajectory up here for oil continues through the next 20 years, and here, like next 40 years, still is on the rise. Eventually, it seems to taper off. And does anybody want to guess or theorize why we have this momentum with oil? I'm going to kick up renewables. What's the deal with oil and coal and gas? I mean, oil eventually winds its way down because we've got electrified cars. But why does it continue up? Anyone want to guess on that? I'll say your guesses have been right on so far. Oil and gas and coal, well, oil and gas have a lot of infrastructure that contributes to their costs. The cost of finding new deposits of fossil fuels and the cost of building pipelines to transport the fuels from place to place are sunk costs which have a long life. The life of a pipeline is 20 or 30 years. So utilities have made investments, of course, over the last many, many years, and are still making investments. So those pipelines are still in use. So if you have a pipeline and you have a source of fossil fuels and a refinery that's already up and built, there's a lot you can do to have relatively inexpensive fossil fuels. And of course, as we know, we're not including the external costs of those, the impact of the environment and the air, and of course, global warming. But setting those aside, which our policies generally have set aside, they haven't accounted for those external costs. Setting those aside, we have those pipelines, which from a simple economic viewpoint, if you're just looking at the cost of fuel, can be a big contributor to keeping oil and gas a very attractive in terms of price source of fuel, source of energy. So that's why they continue on. Basically, a lot of infrastructure that's already in place. Yeah.
So Clark, on that note, I think we've got a question is maybe we can look to include the cost of carbon in and the effect it has on society.
Okay. So we've got renewable subsidized, we've got some methane, and we've got some things electrified. What could we do if we did a price on carbon? So we would charge for the carbon content of things that are burned. So I'm going to put this, let's say, 3/4 of the way up, and we'll talk some more about this in just a couple of minutes. Does somebody want to guess what's going to happen? Now we're gonna take that transport, those batteries in cars, and we're gonna charge them with the fuel that becomes the least expensive when there's a price on carbon. So if there are any voices out there, speak up, but otherwise I'm gonna move my carbon price up here. Okay, so green is kind of hitting it out of the park, you could say, because the carbon price does not impact renewables, other than probably parts of the manufacture of the solar panels and of the windmills. But in general, the production of the energy isn't getting that carbon fee applied to it. But the other fuels are really driven down because they are emitting carbon as they're burned, and they're very much depressed. I want to point out one other thing. Remember, a minute ago, we had oil and gas with a lot of momentum here, and coal as well, continuing to go up and not getting to their highest point. Let me turn this on and off. Here's carbon price going on and off. Coal, the brown one, that's really going down. And even oil is depressed. Now it's got a peak somewhere around 2030 instead of 2050 or so. So coal is going down right away because on day one, they're going to be hit with with just this policy change, they're going to become a lot more expensive. And the reason they're saying it's so significant, or in part, is coal is the most carbon intensive of the fuels. So for unit of energy you get out, coal really has a lot of carbon emissions. So they're going to get hit real fast. And even oil and gas are going to be hit. And let's take a look at what kind of a price we've got. Here we have an increasing price on oil. I'm sorry. Here we have an increasing price on carbon, which is goes up from the year 2020 to 2030 and then stays steady state. So there would be a possibility that we could have a carbon price that would go and continue to go up. And in fact, Citizens Climate Lobby is proposing a price on carbon that is $15 the first year and goes up $10 every year after that. And that's that $15 per year the first year is roughly accumulate the same as 15 cents a gallon in that ballpark, and that $10 a ton fee for subsequent years would be roughly 10 cents a gallon for gasoline. And so after 10 years, you're looking at maybe $1 per gallon for gasoline, and a comparable fee also on other fuels, natural gas and coal. And
Clark, I think Ruth has a point about the use of oil for, I guess, non-vehicular purposes. Ruth, I think you're unmuted, so if you want to go ahead and ask a question.
Hi. I was watching a film the other night, which was particularly looking at plastics and with the concern of, in the ocean and all that kind of thing would be sort of the primary source. But it seems like they were saying that fossil fuel producers sort of see that the whole vehicle use thing towards electrical is coming, and that even using them to heat and do that sort of thing is going to be a push to not do that globally, but that in order to protect their investments, there has been and will be ever more a push for more plastic used in production of new products, and that is one way that, I mean, it's sort of like they're going to transfer what we're now using for energy for transport and heating, and try to transform it into a new sector of products. And unless that is somehow addressed, we're not going to push them down. They're going to continue to expand.
So did you mean that the oil is used as energy while producing these products, or is it a raw ingredient, sort of raw material for these products?
It's a raw ingredient in the production of plastic.
yeah, okay. Plastics are a petroleum product, and so if you're you have refineries or you have a source of fossil fuels, oil, then you could, if I'm hearing your question right, what about that could be diverted and you could keep your pipelines running because you make more plastic?
Yes.
Yeah. In the scope of possibilities, that's there for sure. But like in this case, we're talking about a carbon price for fossil fuels that are burned, and plastics are a diversion for that. And my understanding is in their production, I mean, there's energy to produce them, to change the form from crude oil to plastic, but there's no inherent production of carbon that's emitted into the atmosphere. If later they're recycled, or not recycled, but often if they're incinerated, that's a whole other thing. But the carbon price addresses the use of fossil fuels as an energy source. That's its main focus of the carbon price. And what you described, I think it's completely possible, but it's really a different aspect of this because it's a different need that would be satisfied. They would have lots and lots of incentive, let's say, to if they want to keep their pipelines running and their oil fields running, they'd have a lot of incentive to try to produce products that people would want that are made out of plastic, or incorporate plastic into whatever. But that would be the challenge that they'd be facing. And I think there's probably going to be some societal pressure at that point, even more than there is now, on, hey, how are we going to regulate all that plastic production? And the price of plastic is very, very low. And so now we're just going to get more pollution from plastic. And in my opinion, we have a huge problem with that now, with single-use plastics. And I think I agree with you in that it's just going to exacerbate that problem.
I guess
yeah.
One of my other questions along that line is, it doesn't take care of the extraction aspect, meaning that there is in fact methane, certainly that's released during the process of production. And so anyway, I don't know if a simulator like this would be taking into account that if you continue to pull fossil fuels out of the ground, even for other uses, there's going to be some sort of leakage, if you wish.
Right. Yeah.
So,
Right. The whole nature of extracting it and making some use of it. So I haven't looked at all the equations, so I can't answer that authoritatively, but my assumption is that some of that is comprehended here. But I think that the encouraging thing to think about and to look at is where we are now with oil use on this graph and where we would be with this carbon price in place. We're going to put tremendous downward pressure on the use of oil as a fuel. And will we still have some leakage? Yes. And here we've simulated that we're going to put some things in place to better monitor our methane. Maybe I think in Europe they even have better regulations as far as lost methane. But I think it's not a trivial concern. I think we will still have to go back and say, hey, where are we getting greenhouse gas emissions from? The job of putting a price on carbon, the mechanics of it are, in my opinion, very simple. It's pretty easy to monitor. We know how much is being delivered to people's homes and into their gas tanks. And so that would be the place. That's why I'm working with CCL, because I'm very excited about the prospects for the effects of a carbon price. Methane is a little bit harder to detect. Its leakage is hard to detect. And I think we need to put some emphasis on that. But the biggest bang for the buck here is carbon pricing, I think. I mean, it just does an incredible, has an incredible impact. And as we can see, so we were at 3.1, and with this, we're down to our 2.0. And methane was a big contributor. That was 2.4. If we do more with methane, we're not changing it, but let's see what we need to do to get to 1.5. We could, let's see. Oh yeah, energy efficiency of our transport systems, we could increase that. We could increase our energy efficiency, put more of those windows of David's, higher efficiency windows.
Clark, do we know if the carbon price you set sort of matches CCL's carbon price, or is it lower?
Let's look at
meaning the carbon price from. Yeah.
So we looked at this graph before. So this is a relatively minor increase in or ramping up of carbon price. We could increase this quite a bit, but actually somebody within CCL has done a simulation where they looked at a carbon price comparable to a bill that's in the House now called House Bill 763, which it's the one I described, $15 a ton the first year, and it goes up $10 each year. So the one we simulated a second ago just went up here, and then it was a straight line. Now here's the one that continues to increase, and it just continues and continues. And so with that, we're at 2.6, but with no other changes. So if we put in those changes we had before, we electrify the fleet and we have better efficiency, we regulate methane, we have forestation, deforestation. Now we're at 1.8. Let's see, we could do some renewables. And now we have half a chance of getting to 1.5. Let's see, what else do we need to do here?
Maybe technological carbon removal.
Yeah, we could do some carbon removal. And by the time we're at, $700 or $600 or $700 a metric ton of added price to our fossil fuels, things like carbon capture and sequestration, technological methods for capturing carbon, or like injecting it down into rock formations and things, that's going to become more economically viable.
Clark, I'm interested in the difference between a moderately high carbon tax and the maximum carbon tax.
So you mean here? You mean here and what we did before? Let's see.
Yes.
We can, yeah. Good question. Right now we've gone all the way to $850. And let's take another look and not go as high over the same time. So even with that, let's see, we can turn that on and off. So even with the more moderate price on carbon, we get a significant reduction down to 1.9. And just for grins, let's reassure ourselves, if we take off our price on carbon, oops. Oh, I can't do that with one swing. Let's go back. I'm going to go back to our other simulation with as a more modest. And if we take it on and we take it off, we get to 1.7. So even without that significant of a, so we've got, let's see, apples to apples. Move my methane up. What else? It's different. Let's see, what have I got here? I got 1.7 with our 1.7 degrees with our more modest carbon pricing, and I actually have not even as much with this. See, what else? Oh, I got methane, electrification. That's a good question.
Clark, I think if you go to the detailed settings for carbon price, I think you had reduced it a fair bit in the other one. If you go to the detailed settings.
Am I at 200? Thank you.
Yeah.
Yeah, so it never got up that high. So this was the original, the bill that is in Congress. Okay, yeah, thanks.
I'm sorry, the bill in Congress doesn't have $847 per ton of CO2.
By the time you're at 2080, it does.
I see.
It doesn't. This was one that Rick Knight from CCL put together to say, well, this is a lot like it, and people debate how much we know about how well we can estimate what will happen by the time we get this far out, and we know that when prices on carbon get that high, there are going to be other effects that are a little bit hard to model, which will include things like tremendous pressure on energy efficiency and transport. So it could be that we need to move some of these up just because a high price on carbon makes it attractive for instance, automobile manufacturers to make highly efficient fleets, even more so than simply the way it is now. We have electrified vehicles now, but if you add a carbon price, it becomes a lot more attractive to more people. So we're a little bit over time at this point. Was there anything else people wanted to look into? I can just show, and again, you can call this up at enroads.org and run the simulation yourself. It's possible that you can, like this particular scenario, I can just grab this URL and I can send it out, and that would allow you to just plug in this URL and you would get the same graph, set of graphs.
Yeah, I think Ruth has a question about where we'll be actually in 2030 with carbon pricing in place.
Where would we be in 2030?
Yeah, because I think these graphs are all showing the temperature changes for 2100.
Yeah.
So what do things look like in a shorter term?
Okay, so here it shows we don't have a big swing above 2 degrees. We are actually at 2030, we're right around 1.5 degrees of change, and then we creep up above it, but things are under control here. Does that answer your question, Ruth?
Ruth, I think you're muted. You're still muted. Could you unmute yourself?
Sorry. I guess I was trying to think about if it went into effect, the carbon pricing bill got passed and went into effect this year. We've got 10 years, and that 2030 is kind of considered a critical year in terms of changes that have to be made so that we, everything isn't so on automatic pilot that it's just going to be pushing us up. And so I guess what we're saying is that if it went into effect, is the graph that you're showing us right now on temperature change, if it went into effect in 2021 even, that it would stabilize it below the within the range that we want it to stay.
Yeah, I'm gonna flip to the other one, but right now I'll just show this is the price on carbon for this simulation, and it starts at 2021, and it isn't that high in the next 10 years. But part of the human nature part of this is if we have some confidence, and if industry has confidence, and that the price on carbon truly will go up as projected, then there will be a reinforcing effect of manufacturers planning for that and consumers buying into it, knowing that, for instance, gas prices aren't going to magically drop next year or in the next 5 years. If you can show that graph to people and say, hey, this is what's going to happen to carbon prices, everybody, they'll obviously have an incentive to make changes, but if they have that confidence that it's going to stay in place, that the carbon price increase, that ramp will continue, then they're going to be more likely to invest in it. And that's part of the reason, too, that Citizens Climate Lobby is nonpartisan and puts a high value on including all conservative and progressive people and all political parties in the solution. That this needs to be durable. It needs to last through different administrations. As challenging as the environment is now, this legislation is not going to help us out much if it lasts for only 4 years. So we really, the challenge that we see is to educate more people, and I want to just make that little pitch here. If people know of groups that might be interested in Citizens Climate Lobby, our Ann Arbor chapter is very active, and we would love to come and host a tabling event or go and talk to Rotary groups or church groups or school groups and educators. Really, our standard isn't too high. If the group meets, we'll be happy to talk to them. So I just want to mention next week, one other thing about the simulator and what we learned tonight. For one thing, there's no single silver bullet. Not one, just changing one of these sliders did not do what we want. it's like the originators of this simulator called it silver buckshot. A lot of little changes or a lot of significant changes will get us to limit the temperature where we need to, but it's not any one change. And also just it's nice to note, and you can always refer back to the simulator. And some of the changes you think might be very significant weren't that impressive in their results. Putting all the trees in, and deforestation is also one of those where if you make a change, if you keep the rainforest intact, that's good, but it doesn't really have that much effect on climate. It's really good for biodiversity, good for other reasons, but we have so much going on in our fossil fuel use. We use so much, and we're putting so much in the atmosphere that reducing our deforestation and preserving the rainforest doesn't have that much effect on climate. But, all is not lost, and that's where I find a lot of encouragement in Citizens Climate Lobby, that they've got a solution. We talked a little bit about it here. This carbon fee and dividend, where we charge a fee on fossil fuels at the source. A relatively simple thing to do. It's very well monitored. That money is all collected. The U.S. Treasury takes it in, and then it's paid out as a monthly check to households in a equal share. So every adult gets the same amount, and people under 18 would get half that amount. And as I mentioned, the plan is for $15 a ton at first, which is roughly 13 or 14 or 15 cents a gallon in the case of gasoline. And then it goes up $10 per ton each year and continues up. And Ellingson next week will talk about how this carbon fee and dividend helps protect low and middle income people and is equitable over a lot of other options. But let's see, that's the end of our slideshow. I think I'll go back to stop sharing. Were there other questions people might have? We're going to be here at the same time in channel at 8 o'clock next week for those interested. And this program is being recorded, and the prior two programs were recorded. So if there's an interest in knowing about health and climate or impacts in the Great Lakes, those programs are watchable. Any other inputs, or we'll close this meeting up? Okay, thanks everyone for participating. I hope to see a lot of you next week.
Thank you, Clark. Great job. Thanks everyone
Great.
for joining.
Thanks, everyone.
Great, thanks for participating.
Thank you.
Yep.
Clocks, please. Okay. So I guess we're meeting tomorrow as well, right? So